Practice Set 4. You can determine the sine ratio using a graphical method, table, or scientific calculator. The following problems will give you some practice using each method. Ultimately, you will use the calculator exclusively. Number 1 asks us to determine the sine ratio of 11.5 degrees. We're going to measure these lengths in millimeters. So we're given this acute angle that has a measure of 11.5 degrees. In A, it asks us to measure the distance from the vertex to the tick mark on this horizontal line. So placing my ruler and starting at the 0 mark on my metric side of my ruler, we have 10 millimeters, 20, 30, 40, and we're right at 49 millimeters for the length of this line from the vertex to the hash mark. Next, going straight up, measure the distance from the tick mark to the angled line. So we'll take our metric ruler and we're looking at the distance, and if I start here at the 1 centimeter, each one of these hash marks being millimeters, and I measure and count, the vertical distance looks to be 11 millimeters. We've now formed a right triangle with our horizontal distance that we measured of 49 millimeters, our vertical distance, or this leg, 11 millimeters. It asks us in C to measure the length of the hypotenuse, the longest side, and write our answer there. So again, using the metric side of my ruler, 0 at the one vertex end and measuring to the vertex or endpoint of the hypotenuse. It appears to be 51 millimeters in length. In C, it also asks us to label the sides of the triangle using the terms hypotenuse, opposite, and adjacent. Always start with the hypotenuse, the longest side, opposite the right angle. Next, even though it's not a designated angle, this is the angle with the measurement, so we'll treat it as our reference angle. That means through the triangle, this length here is opposite, and the side unnamed is our adjacent side. In D, it asks us to use our measurements to write the sine ratio of an angle measuring 11.5 degrees. So we want the length of the opposite side. The opposite side we found in B to be 11 millimeters, and the hypotenuse length we found in C, which was 51 millimeters. In E, it asks us to divide the opposite by the hypotenuse value, so we will take 11 and divide it by 51, the ratio of the opposite side length divided by the hypotenuse side length, which happens to be the definition for the sine of an acute angle in a right triangle. And for us, rounding our answers to 4 decimal places, if you take 11 and divide it by 51, the measurements that I got, and you may find some variation depending on the copying of this page and this assignment. For my particular measurements, I am getting a value of 0.2157.